All right, so solving inequalities is just like solving equations, but when you multiply or divide by a negative, remember to flip your inequality sign. All right, so what that tells us is, oh, that glitched. All right, what it tells us is I'm treating this just like an equation, except I have to treat this greater than symbol a little bit differently. All right, which is not bad because we just did a whole unit on equation solving. All right, so I want to get the Q alone. What's my first move? Okay, in this case, you could do that. The reason why you could do that in this case is because each one of the coefficients are multiples of 5. All right, so that's a good observation. Not always going to work. You know, if that instead of having a 10 there, it was like a 7, then you're introducing a fraction. Still a legit move, but you're making it more complicated. But by dividing everything by 5, you just made the equation much simpler, so that's great. So now what do I do? Subtract both sides, yeah. Take that 2 away. And we'll have Q is greater than 2. Q. And a fun fact, a Q is not a Y. Q is greater than 2. All right. So it's asking what's the solution set to the inequality. Now this part you might not like because it feels like we have the final answer, but the proper set notation, so I'll write it here, set notation, defines the variable in a squiggly bracket, the best you can, because I know not everybody is proficient in the squiggly bracket making. A vertical line, and then your inequality. All right, so this is a statement telling what the variable is. That vertical line means given. And then the other part I think is obvious, that's the solution to the inequality. So what this reads as is Q, given that Q is greater than 0. All right, Q is the variable. You can even think of it like most people just kind of put it in their own words. Q where Q is greater than 0. Q is the variable and Q is greater than 0. Q is the variable so that Q is greater than 0. Any words that gets that idea across is sufficient. All right, but that notation you need to be prepared to write it. You might not like it, but it could be requested on the Regents exam. They could say put your answer in set notation, in which case if you don't have it in this form, you're losing credit because you're not answering the question in the way they asked. All right, so express the solution set in words and set notation and graphically on the number line. So we got the set notation. All right, in words, Q has to be more than 2. All right, and graphically, what we would do is plot an open circle around 2 and shade on the graph to the right. All right, open circle, I'll make a little note. Open circle does not include the value. All right, So the common question I get usually at this point is, okay, so instead of doing that, couldn't I just start my number line at 3 and go from there? My answer to that is, well, then you're excluding all of those real numbers in between 2 and 3, right? So the 2.1, the 2.37924, you know, like all those decimal values and fractions that exist between 2 and 3. What the open circle does is it tells me that I'm getting very, very, very close to 2, but I'm never actually touching it, all right? So that's the proper notation there. Now, number 2 is asking us to basically do the same thing, but we have a fraction, and then also we got some negative signs, so we'll handle this one. What do you think my first move is here? Multiply both sides by 4, okay. Yeah, I would go -4. Everything's already negative. If I multiply by -4, I can wipe out all those signs. All right, so I'll be looking at x, and when I distribute this through, x plus 24. Now, I have a less than or equal to symbol here. What's going on there? What's going to happen? Flip it. It's going to become greater than or equal. All right, if you divide or multiply both sides of an equation by a negative number, the result is that the inequality is going to reverse itself. So instead of going to the left, it'll go to the right, or vice versa.
Wouldn't x be negative because if it's a negative fraction, only one, either the numerator or denominator can be negative?
Yeah, so if we assign that negative to the numerator, when I multiply it by -4, that -4 is only getting multiplied by the numerator anyway. Okay. So it'll become positive. Now, if I assigned it to the denominator, that -4 is still only getting multiplied by the numerator. So it'd be -4x over -4. It would cancel. So one way or the other is going away.
Okay.
All right. And so we'll get 20 on the right-hand side. So now I'm going to subtract the 24. And I get x greater than or equal to -4. All right, so this is my inequality. If I wanted in set notation, very simple adjustment. Just draw a vertical line, put an x to the left of it, put your squiggly brackets, and that's the proper notation for your answer. All right. So it's really nothing crazy. It's just an additional step that you have to remember. All right. Which involves studying, but you know, it's not like complicated studying. It's just, oh yeah, I have to do that too. All right. So here, what I'm going to do is I'm going to plot a closed circle at -4. So closed circle includes the value. And then I'm going to shade to the right because I'm looking for all values that are bigger than or equal to -4. All right. This is all familiar, right? You did this before?
Yeah.
Yeah? Okay. So that's good news. We'll do one more and then I'll set you loose.